Hello, welcome to Lancaster Hi-Fi. This is part 3 in my series on the build of a DG SE1 tube amp. Part 1 went over the schematic. Part 2 went over the planning of the layout in the chassis. And part 3, this part, deals with cutting holes in the chassis and fitting the major components. This video series is focusing on a build I did last summer in July and August 2022. But I have included footage from other builds because the footage that I had from last summer isn't comprehensive enough. Enjoy the video. I'm building this single-ended tube amp based on 6BQ5 or EL84 tubes for the outputs and 12AX7 triode tube on the inputs. Hello, welcome to Lancaster Hi-Fi YouTube channel. I'm working on a build of a DG SE1, Dave Gillespie single-ended 1 amplifier, which is a modified 8600 series Magnavox. I've got the chassis here stripped of everything but the tube sockets and one of the lug strips here, terminal strips. I have here before me some amplifier components. Power transformer, output transformer, other output transformer, choke, chassis, and bottom grate. I've got to figure out exactly where to put these things, drill the holes. Also put in holes in the back for speaker terminals here and a power input module here. Check out this chassis. Polished it with mothers, inspected it carefully to see whether I was going to still need to put some Rust-Oleum clear coat on it, and I will, because I don't know if you can see it. You can barely see there right next to the 6CA4 socket there. You can see some flecks where the plating is corroded. And so in order to keep that from becoming a problem, we're going to need to put Rust-Oleum on there. Coat the whole thing. That's why I've got the masking tape on there. One of the problems you can run into when you're clear coating something you've polished is that the polish contains acid, and the acid's not compatible with the clear coat. It'll make it flake off. One thing I've done in the past is to clean the chassis with a solution of baking soda and water, but it tends to leave it looking not so nice. So I've tried this time just regular countertop or multi-surface cleaner, cleaning it thoroughly with the cleaner to see if I can get off enough of the residue that it won't interfere with the clear coating. And so we'll just see. If I have to redo the clear coating, then that's what I'm going to have to do. But I thought it was worth the experiment because it does look so nice and shiny, and I don't want to dull it with the baking soda. I know from experience that the holes for the choke can be attached to these holes here in the chassis, and that I can feed the wire through this big hole, although I'll need to put a nick or two in it to get those wires through without rubbing on the chassis. What I don't know exactly is how to fit these. These are substantially bigger than the original output transformers, and they're substantially bigger than the output transformers that I've used on previous builds on the 8600 series chassis. I have built an amplifier with these transformers before, but it was on the Amp 196 chassis. I think I figured out reasonably well how this is going to go. I'm going to probably have to fold down one of the tabs and actually connect it to the back side here so that these can sit right at the edge of the chassis, something like that. On the previous builds that I've made, I've kept the original can multicap on the top, which would go over this square right here. My original plan for this was to similarly keep the can cap on here, to hollow it out, put in the new capacitors for the power supply. But with these larger output transformers, there's just not going to be room for that can cap on top. So that makes that decision for me. I don't have to hollow that thing out and repack it. So what I need to work out is just where exactly the holes are going to need to be for these transformers and drill those holes. Now I've already polished and clear coated the chassis, and it's come out pretty nicely. Now, complicating matters is the power input module. Previously, I've put it over in this corner, and I still think that's really the only viable place for it to go. However, it's just about as thick as the chassis, so it really barely fits under here. So you can see if I put it under there where it goes, there's really not going to be room on top of the power input module for bolts holding down the output transformer. So I got to work that out. It's a trick. I can't put it right here. Even if this is far enough, I can't fasten it to the back because the power input module takes up the whole back of the chassis right there. So I suppose I could put it like that, but the power input module needs to go really right up next to the side of the chassis right there. So again, there's not really room for any bolt to come in from the side. I could something like that, but there again, it's not room. Okay, I think I've worked out a configuration that just might work, and if it doesn't, I'm kind of screwed. All right, so you can see here's one of the output transformers right here, and then the other one right here, and that's kind of good when they're so close together, having them perpendicular to one another. And then this one is essentially straddling the power input module so that I can bolt it down here and on the far side of the input module over here. And then just have room for the wires from the output transformer to go in at the end of the input module over here. Boy, this is going to be tight, you know, but it's a small chassis. And, you know, it was always going to be kind of crammed. Even my previous builds have been pretty crammed, especially with using the power input module. My one concern really is where am I going to fit the capacitors that would have gone in the can that's displaced from the top. And I think there will be room for those somewhere over here near the rectifier tube, which is going to go here. Boy, it's going to be tight in there though, but I think it'll work. And it's, you know, it's part of the neat thing about this amplifier that it's all on this tiny little chassis. So you will note that all of these pieces are painted nice shiny black, and that's using this Rust-Oleum Ultra Cover Gloss Black. Okay, so I think I've got the output transformers worked out so that I can use this hole here and put a new hole here, and this hole here, and put a new hole here. While I'm out here with the drill, I'm also going to make some isolation washers out of these pieces of butyl rubber to put above and below the chassis on these bolts that hold the transformer down. Because these old transformers do tend to have some buzz to them, and that buzz can resonate with the chassis and make an audible buzz. These can, in some cases, eliminate completely audible buzz from a transformer. I found it to be necessary in enough cases that now I just do it routinely. You can also just see where I've already put some indentations with the center punch for these. Well, one of them will be dark brown, two of them will be red, which are used as test points to set the bias. And then two more little bitty holes. These will each be about 2.5 millimeters in diameter for the trimming pots. Little screws for the trimming pots will stick up into those holes to allow setting the bias from the top. Okay, so I've got my center punch here. Pull this out and make the necessary indentation here. And over here. Let's get up close and personal with some of the tools that I use to cut holes in chassis. This is a diamond wire saw. It's a method that was recommended by Morgan Jones in his Building Valve Amplifiers book. Right now it's not tight. So the idea is you've got this pretty thin wire. This is like 0.5 millimeter or something like that. And it's coated with flecks of diamond. So it cuts through steel pretty well, and it cuts through other metal really well, but mainly I use it to cut steel. So how do you use it? Well, you unfasten one of these, like so, and then your diamond wire is loose. You have to have a starter hole, maybe that you drill, or that's already in the chassis, and you're just trying to make a larger hole at that location. So you stick this through the hole and then refasten. See that quick? Okay. Okay, then we also have this degree of freedom here. So we want to get it good and tight, so while it's in the hole, then typically I sort of grab with these fingers, push with the thumb, get that wire good and tight, and tighten the thumb screw like so. And then you're off to the races. Now that I've finished cutting out the holes with the saw, I'll use files to finish the holes. Let's talk a little bit about getting holes the right size and why it's necessary. So here's an RCA jack. It's got this little ground tab thing. Alright, so what's the deal with the RCA jack? Signal goes in the middle there, and then the ground is on the outside. Back in the day, they would have just grounded it to the chassis. But that's not generally recognized as the best way to do it anymore. Hence these plastic washers on here. So let me show you what those look like. Alright, so one is just a plastic washer, no frills, no muss, no fuss. And we got this thing. That's not where it would end up though. So this one has this lip on it. The idea is that that part goes inside whatever hole you cut in the chassis, and then you sandwich the chassis with the other one, and now you've got insulation. You've got isolation of the metal body from the chassis. It's tricky though. I mean, well, you got to get that hole in the chassis just big enough for that to fit in, but you don't want it much bigger than that. And the 5-way binding posts have a similar deal where you've got the sort of lip of plastic that's supposed to fit in the hole, and part that's not, and it keeps the 5-way binding post isolated from the chassis, which is even more important. Let's look at some drill bits. So these are labeled cobalt. But these are in the class of what you'd call high-speed steel, I think. These are hard enough to drill through steel pretty easily, and they seem to stay reasonably sharp. And then here's something a bit more specialized, a little more special. These are step drill bits, both from relatively small. This one much longer, I guess more gradations. Starting off, you know, you can get pretty small holes with this one. And these are pretty dang effective. I haven't been using the step drill bits as much lately just because these seem simpler and easier somehow. But these are probably really your best thing for putting holes of a certain size into metal. Of course, the problem always with putting a hole of a certain size in metal is that it always ends up a little bit bigger. Or, well, with the problem with these sort of bits, and especially as you get to the larger ones, the holes can come out irregularly shaped with these. The bit gets wonky through there. That's typically less of an issue with the step drill bits. They're interesting to use. Like you can see, for example, here where I've made a mark with a Sharpie, because that's the step that I want to stop at. Sort of works all right. All right, let's drill some holes. It probably goes without saying, but in case it doesn't, gotta have high-speed steel bits to drill into steel. Or carbide. Carbide's awesome, but very expensive. I use carbide for work to drill into rock, but I also use a drill press with a directed jet of water to cool the spot. Here, just use a dab of some kind of lube. I don't like the positioning of this indentation. I'm going to see if I can move it just a little bit. That is, make a second indentation. Don't like that either. Okay, I'm going to go with 3/32. Okay, I need to measure the size for test point holes. These are made so that you can use non-circular holes, but trying to make non-circular holes is just a total pain. And it's not so critical that these be super duper tight. And generally they get plenty tight with just the fastening hardware. So I will go with a round hole, which needs to be about 7.7 millimeters in diameter. Okay, I'm going to go with, I think, the 5/16. Yeah. Now, luckily, these larger bits do have little center finding points on them. Yuck. All right, I've got all the holes. Got 2 more holes here for the 5-way binding posts. I've got these 3 holes for the test points. I've got these 2 little holes here for the little screws on the trim pots for setting the bias. I've got a hole here for mounting another, whatchamacallit. And I've flattened this, whatchamacallit, ground prong so that I've got a hole there instead of that kind of shape for mounting another one of these thingamajiggers on the inside like that. Now the holes aren't perfect. It's hard to make perfect holes in steel, especially steel that's this thick and heavy. I do need to get this one off. I removed the rivets for the inputs, but those inputs are held on by solder, so I'll need to get in there and melt that enough to pull that out. In addition to putting in the input power module and the 5-way binding posts, I've also put in the test point terminals. You can see here the holes for the trim pots. I've got an issue here that I need to deal with. Kind of screwed up, I guess, in positioning the 5-way binding post, the output here, right next to one of the bolts that's holding on one of the output transformers. I checked for continuity to make sure that the binding post here is not grounded. Now this is the ground post. It wouldn't be a disaster if it were grounded, but it's bad design for it to be grounded to that point right there. So I kind of want to just go, it'll be fine. It's not touching, but it is so close. It's so close. It's pretty easy to imagine that it might come into contact someday. You know, the thing gets shaken a bit and it touches. So I need to cut that bolt.
Our love is gone into the night, into the night.
And there we go. That worked out very well. Now there's absolutely no issue with the bolt holding on the output transformer being too close to the terminal for the speaker. That's a relief. I'm going to cut it off there for part 3. So that will do it for chassis preparation and attaching the major components. Next time, for part 4, we'll get into the wiring of the small components. Stay tuned. Thanks for tuning in. Hope I'll talk to you soon. Have a great day.